Chapter 1D, Describing Distributions with Box Plots and Numerical Summaries. Start by reading why learning objectives and vocabulary. So the box plots and 5-number summary that we're going to learn about in Chapter 1D are exploratory data analysis tools that let us look at the data set. These are used for quantitative data sets. So example 1, we're going to find quartiles. So the stem plot below is the travel times to work from 20 random New York State workers. And so part A asks us to find the median, the point in the middle. This is similar to what we did in the last video. So we know the midpoint is between the 10th and the 11th data points. So if we count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we see here this purple bar I've drawn between 20 and 25 minutes. So we can average those two values because we have an even number of data points here to find the average is 22.5 minutes. So that's our midpoint of the data set. So question B asks us how many numbers fall below the median. So we expect there to be 10 values below the median and 10 values above the median. So if you count below my purple fence here, you'll count 10 different commute times below and 10 commute times above. Remember in this stem plot, the stem corresponds to the tens place and the leaves correspond to the ones place. So now we want to find the first quarter of the way through, or the first quartile. And so we count out to find where is the fence between the 5th and the 6th data points. So again, because we have an even number here, 10 data points that are below the median, we're going to have to average the two middle numbers to find quartile 1. So if we count out 1, 2, 3, 4, 5, 6, the fence between the 5th and the 6th data points is between 15 and 15. So when we average 15 and 15, we get that same value. Quartile 1 is 15 minutes. Similarly, quartile 3 is going to be in the middle of the higher 10 points above the median. So if we count out 11, 12, 13, 14, 15, 16, we see quartile 3 is here between the 15th and the 16th data points. So if we average 40 minutes and 45 minutes, we get 42.5 minutes for quartile 3. Here you can see those calculations to find the averages. So we can list 5 important numbers about the box plot or the stem plot. We'll see box plots in a minute. And we call it the 5-number summary. So the 5-number summary starts with the minimum. So in this data set, the minimum is 5. We have quartile 1, which is 15. We have the median, which is 22.5. We have quartile 3, which is 42.5, and we have the maximum, which is 85. So when we see the 5-number summary, we know the value in the middle is the median. We know we start with the minimum. We know this is quartile 1 here. Similarly, the maximum and quartile 3. Here's a box plot. It's a visual graph of this 5-number summary. So we want to check New York here on the right to verify that these numbers match what we just calculated from the stem plot. And we can do a quick check to see that they do in fact match our calculations. Over here is North Carolina, and I did my best to eyeball the 5-number summary from the box plot. So it looks to me like the median is around 20. Quartile 1, I called that 10 minutes. Quartile 3, 30 minutes. The min is 5 minutes, and the max is 60 minutes. So we want to first think about which state has a higher median. So New York looks to have the higher median here at 22.5, a little bit above the 20-minute median for North Carolina. Which state has a lower first quartile? We see here the first quartile, the bottom of the box for North Carolina, is lower at 10 minutes versus 15 minutes for New York. And then we want to calculate what we call the interquartile range. So the interquartile range visually is the spread of this inner box from Q1 up to Q3. And just eyeballing, it looks like New York has the bigger central box, or the bigger interquartile range. So if we calculate out for North Carolina, the interquartile range is Q3 minus Q1, or 30 minutes minus 10 minutes, so that inner box is 20 minutes wide. Similarly, for New York, we're going to do Q3 minus Q1, so 42.5 minus 15 is 27.5 minutes for the interquartile range, and that matches what we saw when we saw that the central box for New York had a wider spread. Overall, if we're thinking about which state has a greater spread from min to max, we can see New York here has a greater spread just by eyeballing the box plots. This is why it's helpful to do side-by-side comparisons of box plots. And then if we wanted to calculate the range is the difference from the max to the min. So the range is 80 minutes. That's the range of the whole data set. Example 3, we're going to see how we can construct a box plot from a 5-number summary. So here's a 5-number summary for students on exam 1 of last semester's statistics class. You see right here in the middle, the median is 79. Quartile 1 is 74. Quartile 3 is 87. Remember, this first number is the minimum score, and the last number is the maximum score. So we want to use the 5-number summary to make a sketch here. So I drew by hand a couple of sketches. So you can see here the median is 79. So that is, I tried to draw a bar right here. I always start by drawing the center bar. And then I drew a bar for quartile 1 down here around where 74 is. My drawing is far from perfect. And then up here around 87, a little below 90, I drew a bar for quartile 3. Once I draw the 3 bars and I connect them up with the lines on the side to make the center box, and then I put a dot or little dash up here at the max, which was 96, and down here at the min, which was 57, and connect those up. Box plots are sometimes called stem and whiskers plots because it looks like these are whiskers on a cat. So you'll hear this called the whiskers out to the max and the min. Exam 2 values are given down here. So the median for exam 2 was 75, quartile 1 was 70, quartile 3 was 83. So you can see I did my best to draw on here a line through 75, a line down here at 70, and then a line up here at 83. And it looks like my drawing is really not so hot. So it looks like I did my best, but it's far from perfect. And then we put a dot or dash up here at the max of 90 and a dot or dash down here at the min of 62. So side by side, we can see exam 2 overall had less spread. The scores were more compressed. Exam 1 had a bigger spread. We see it looks like exam 1's max goes higher than exam 2's max. So we want to compare the IQRs. So if we calculate exam 1's IQR, that's Q3 minus Q1, or 87 minus 74. The IQR there is 13 points. For exam 2, Q3 was 83 and Q1 was 70. When we subtract, we get 13 points there for the IQR. So both exams have a 13-point interquartile range. If we go look at my less than perfect drawings here, it should be that the central boxes look like they're about the same distance apart. So how do we find what we think are outliers? So here in example 4, we're looking again at the summary of the 5-number summary of the travel times for workers in New York. So if we calculate the interquartile range, I think we did that a couple of examples ago. We saw Q3 minus Q1, 42.5 minus 15 is 27.5 minutes for the interquartile range. Now we want to multiply that by 1.5, and we do this 1.5 as a rule to say, all right, we want to go a little bit bigger than the interquartile range. So statisticians at some point settled on this 1.5. So if we multiply 1.5 times 27.5, we get the 41.25 minutes. And then we're going to add that to the third quartile to figure out an upper limit for an outlier. So this is something that we say is unusually far out. So the 42.5 was our Q3. We add this 41.25 we calculated, and we get 83.75. We say this is the upper limit where we would consider values to be outliers. So were there any travel times above this? Well, we know the max was 85, so for sure the 85-minute commute time is outside the limit. So we would classify that travel time as an outlier. That person has an unusually high commute compared to the rest of the data. To find the lower limit for lower outliers, we start with quartile 1 and we subtract that 41.25. And in this case, we get a negative. So there may be scenarios where negatives make sense. In terms of commute time, someone would not report a negative commute time. So we say here there are no negative commute times, so there are no lower outliers. Example 5, this is exercise 1.49 from our open intro statistics text on page 67, gives us a histogram of 224 countries are the data points, and we have the infant mortality rates, and then the height of the bars is what's known as the relative frequency. So they took the count and divided it by the 224 total. So the first task we have is to estimate quartile 1, the median, and quartile 3 from the histogram. So here we've got 224 countries. So we know if we divide it by 2, the 112th country, well, between the 112th country and the 113th country is the median. It's also going to be the halfway point, or where the relative frequency total is going to be 0.50. So since we have the 0.50 here, we can try to figure out, well, where is that halfway point? So if we look from 0 to 10, that's 0.36. All right, so that's less than half. If we go up to 20, and I'm just estimating the heights of these bars, I said that's around 0.22. If we add these up, we get 0.58. So between 0 and 20, we're getting up past the halfway point, past the middle. So that 50% must be between 10 and 20, because we went from 0.36 to 0.58 relative frequency. You can think about the relative frequency as the decimal versions of the percent. You could translate that to 58% of the countries have infant mortality 20 or less. So we can conclude that the median is between 10 to 20 infant mortality rate. Now where was quartile 1? If we look back, we see that first bar from 0 to 10 infant mortality rate contained 0.36 or 36% of the data. So we can say for sure quartile 1 is between 0 and 10 infant mortality rate. Finding quartile 3 gets a little bit trickier. We have to try to estimate some more of these bars out here and add up until we get to 75%. So I estimated these values, and when I add up to 50, saying this bar height is about up to here, let's check and see what I have. So up to 50, I get I think that's up to 40. Up to 40, I get 0.74. I think I made a typo here. I think the up to 40 is a 0.74. And then up to 50 is the 0.06. So we would say here quartile 3 is going to be between 40 and 50 based on my measuring of the bar heights here. Let's go look in StatCrunch at how we could make a box plot in StatCrunch. So if we go to StatCrunch, I've got my SF commute times and my Concord commute times from an earlier example. So if I go to Graph Box Plot, I can choose SF commute times and click Compute, and here's my box plot drawn in here. Now maybe I want to compare SF to Concord, so I can go to Options, Edit, and then I can hold down Control or Command and also select Concord commute times and compute. And here are my side-by-side box plots. We can stretch it out to make it a little bit bigger. If I want to know the 5-number summary for each of these commute times, just hover your mouse over. We're shown the IQR, and then we've got below the 5-number summary for SF, and similarly the 5-number summary for Concord if we hover our mouse over that box. If I wanted to draw these horizontally instead of vertically, we can go to Options, Edit, and check Draw Boxes Horizontally. And one reason we like to sometimes draw the boxes horizontally is it looks a little bit more like a distribution spread. So, for example, if we go to Options, Edit, and we add a marker for the mean, and you know the median is just those center bars. We see here for Concord, the mean is higher than the median, our red bar through the middle. And so we have a right tail or right skew, which is just what we can see in the box plot. and what we saw in an earlier example. And then for San Francisco, we see here the mean is less than the median, meaning there's just a few low values. And so we get a left tail or a left skew here. So you can draw your box plots horizontally to see the tails, or you can uncheck the box and draw them vertically.